Now the next topic is transformation of equation. Uh, let's consider an equation ax cube plus bx square plus cx plus d is equal to 0, and let's say the roots are alpha, beta and gamma. Now what we do in this particular topic is that if I ask you find an equation whose roots are alpha plus 1, beta plus 1, gamma plus 1, then what will you do? If I say the roots are 1 by alpha, 1 by beta, 1 by gamma, what will you do? So if roots are going under a same transformation, the transformation in this particular case was the roots are changed by plus 1. In this particular case was the roots were reciprocal. Okay. Next case is root alpha, root beta, root gamma. Any kind of transformation which is similar in all the given roots. The equation can be degree 4, degree 5, degree 6. So what is need to be done, we will discuss in this particular case. So let's consider the first case as, I will consider the equation ax cube plus bx square plus cx plus d, which is a cubic equation, and I will try to find out the reciprocal root equation for this particular case. Now I want to find the equation 1 by alpha, 1 by beta, 1 by gamma. Now try to picture this thing that these are the values of x in this particular case. Okay, these are the values of x for this particular equation. Now I'll try to find out an equation in y, the value of which is 1 by x. Now my roots will be 1 by alpha, 1 by beta, 1 by gamma, which are the values of y, because I have taken y as 1 by x. So if y is equal to 1 by x, then x will be equal to 1 by y. Now I'll substitute this in the parent equation. The parent equation means the equation which was given. So I will get a by y cube plus b by y square plus c by y plus d equal to 0. Now because this equation is not a real polynomial equation, you have to take the LCM or say cross multiply to get the equation dy cube plus cy square plus by plus a is equal to 0. Now this is an equation whose roots are 1 by alpha, 1 by beta, 1 by gamma, because this is an equation in y. Okay. Now if I'll change the variable, say x, the roots won't be changed. This is also a very important point. The roots won't be changed if you change the variable. For example, I'll just write it here. If I say x square minus 5x plus 6 is equal to 0 has, what are the roots of this particular equation? 2, 3. If you write y square minus 5y plus 6 is equal to 0, the roots will be 2, 3 again. If you write t square minus 5t plus 6 equal to 0, the roots again will be 2, 3 only. So variable does not change the roots, only the coefficients of x square term, x term and the constant term will affect the roots. Okay, so in the end you should change the variable from y to x, because in the options only the equations will be written in x. Okay, so I hope you are clear on this particular point, that if you want to find out the reciprocal roots, I'll try to find out the equation in terms of y. I'll put y as 1 by x, meet the equation in y, and in the end I'll change the variable. Now let's consider a second case, which is ax square plus bx plus c is equal to 0 is a quadratic equation considering roots as alpha and beta, and I want to find an equation whose roots are alpha plus 1 comma beta plus 1. So I'll consider x as alpha beta and I'll consider y as x plus 1. I hope this is clear. Because the new roots are alpha plus 1 and beta plus 1, so I'll make the equation in y. So alpha and beta are the values of x, so y will be x plus 1. But this equation is in x, I want to get in y. So what I'll do is I'll put in this equation x as y minus 1. So the transformed equation will be a into y minus 1 whole square plus b into y minus 1 plus c is equal to 0. So finally I'll be getting y square minus 2y plus 1 plus by minus b plus c is equal to 0. So the equation will be ay square plus b minus 2ay plus a minus b plus c is equal to 0. So this is an equation whose roots are alpha plus 1 comma beta plus 1. Okay, you can finally change the variables. So final equation will be ax square plus b minus 2ax plus a minus b plus c is equal to 0. Okay, so the roots of this particular equations. Let's take one more example. We have a cubic equation ax cube plus bx square plus cx plus d equal to 0, whose roots are alpha, beta and gamma. So we want to find a transformed equation whose roots are alpha square, beta square and gamma square. Okay, so we'll consider x values as alpha, beta, gamma. So y will definitely be equal to x square and x will be equal to plus minus under root of y. Now whether you will use root y or whether you will use minus root y, both will give us same result, because while solving you will get to see that. So I'll just take x as root y. Okay, so the value will be x as root y. If you put in the equation, the transformed equation will be ay raised to the power 3 by 2 plus by plus cy raised to the power half plus d is equal to 0. Okay, now because you need to this is not a real polynomial equation. Okay, this is not a real polynomial equation. So what you need to do is you need to remove the radical signs. So what I'll do is I'll write ay plus c into y raised to the power half is equal to minus of by plus d. Okay, now scaling both sides, what we will get is you must be remembering this thing that because there are three roots, the degree of this particular equation should be 3. Okay, so if I take scaling both sides, so I'll get a square y square plus c square plus 2acy into y is equal to b square y square plus d square plus 2b dy. I hope it is clear that because the degree was 3, we need to we need to do the scaling on both the sides. Even you would have taken minus root y, the result would have been same. Okay, so finally we'll be getting the equation as a square y cube plus 2ac minus b square y square plus c square minus 2b dy minus d square is equal to 0. Okay, finally we will be converting it into x cube by changing the variable 2ac minus b plus c square minus 2b dx minus d square equal to 0. So roots for this particular equations are alpha square, beta square and gamma square. I hope it is clear. Now moving on to the next topic, which is the relation between roots and coefficient of an equation. In the quadratic equation, you have already discussed that sum of the roots taken one at a time, which means that alpha plus beta is minus b by a, and product of roots is c by a. So we just want to extend it now to cubic equation degree 4 equation degree 5 equations, and we'll be detailing about that. So let's consider a polynomial equation in degree n where an is not equal to 0, and the equation is anx raised to the power n plus an minus 1x raised to the power n minus 1 so on to a1x plus a naught equal to 0, where an minus 1, an minus 2 so on to a naught are the real numbers, and the coefficient of variable of different parts of x, and alpha 1, alpha 2, alpha 3 so on to alpha n are the roots of this particular equation. Now if I'll say sum of roots taken r at a time, what that means is I'll be taking the terms alpha 1, alpha 2, alpha 3 so on to alpha r, and all the groups which will be containing r roots of the equation, and if I take the sum of those equations, I'll get this term sum of roots taken r at a time. For example, if I'll say sum of roots taken one at a time, sum of roots taken one at a time, okay, what that means is alpha 1 plus alpha 2 plus alpha 3 so on to alpha n. Okay, now if I'll say sum of roots taken 2 at a time, what that means is I'll denote it as alpha 1 alpha 2, which will be same as alpha 1 alpha 2 plus alpha 1 alpha 3, alpha 1 alpha 4, plus so on to alpha 1 alpha n plus alpha 2 alpha 3. Don't write alpha 2 alpha 1. The pair should be distinct. Don't write the pair which you have already written once again. Alpha 2 alpha 4, alpha 2 alpha 5, and so on till the last pair, which is alpha n minus 1 alpha n. So I hope you are clear on this term, sum of roots taken r at a time. What that means is, if I'll write sum of roots taken 3 at a time, it means alpha summation of alpha 1 alpha 2 alpha 3. So this will be equivalent to alpha 1 alpha 2 alpha 3 plus alpha 1 alpha 2 alpha 4, and so on to alpha 1 alpha 2 alpha n. Now the next pair will be alpha 1 alpha 3 alpha 4, alpha 1 alpha 3 alpha 5, and so on. So all the pairs which are possible. Actually, if you might have studied about the calculation of number of pairs, it will be studied in the chapter permutation combination. It will be in this case NC1, this will be in case of 2 is NC2, in case of 3 the total number of terms I'm telling here will be NC3 terms. Okay, in this case it will be NC2 terms. Okay, if you haven't studied about this, you will be studying in the chapter binomial theorem or PNC. Now let's move on to the formula for this particular summation, and then we will try to check it. So sum of terms taken r at a time, or say sum of roots taken r at a time, we write this as sum of roots taken r at a time. It means actually we are doing the product of r roots, taking 1 1 1 at a time, and then we are adding them. So we'll denote this term as alpha 1 alpha 2 alpha 3 so on to alpha r, and the formula for this particular calculation is minus 1 raised to the power r coefficient of x raised to the power n minus r upon coefficient of x raised to the power n, where n is the degree of the polynomial. Okay, so this is quite important. You should remember this thing, and it is not very tough to calculate this particular formula. It can be derived easily using the expansion of equation and by comparing the coefficients. I'll just try to check it. We are not deriving it here. We are just trying to cross check this formula whether this is right or not, or how to apply this one. Let's say I'll write the equation ax cube plus bx square plus cx plus d is equal to 0 as a times of x minus alpha, x minus beta, x minus gamma, which is the expansion of this term ax cube, bx square, cx plus d, and say alpha, beta, gamma are the roots of this equation. Okay. Now if I compare this both the sides, I will get ax cube plus bx square plus cx plus d. This is equal to a times of, if I multiply these two terms, I'll get x square minus alpha plus beta x plus alpha beta into x minus gamma. Okay. So finally I'll be getting x cube minus alpha, this will be x cube minus alpha plus beta times of x square plus alpha beta x minus gamma x square, okay, plus alpha gamma plus beta gamma x minus alpha beta gamma. Okay, so by comparing, I can easily write this as x cube plus b by, I'll just divide with a, b by ax square, c by ax plus d by a, which will be x cube minus alpha plus beta plus gamma times of x square plus alpha beta plus beta gamma plus gamma alpha x minus alpha beta gamma. So if I compare both the sides, I can easily get alpha plus beta plus gamma is minus b by a, and we are taking this term as s1. Okay, now if I'll write alpha beta plus beta gamma plus gamma alpha, this is c by a, and we are taking this term as s2, sum of roots taken 2 at a time, and alpha beta gamma is minus d by a, we are taking this term as s3. Now this I have calculated by using the expansion which I was telling you. Using this also we can derive for the nth degree term. Now I'll just try to use the direct formula to calculate this thing. Ax cube plus bx square plus cx plus d is equal to 0. Say I just want to calculate S1, which is which is summation alpha, which is actually equal to alpha plus beta plus gamma. This will be minus 1 raised to the power r. R is the value here. If you see in the formula, the SR denotes the value in which we are stating sum of roots taken r at a time. So S1 is sum of roots taken 1 at a time. So minus 1 raised to the power 1, coefficient of x raised to the power 3 minus 1 upon coefficient of x raised to the power 3. So the value will be minus coefficient of x square, which is b by a. So S1 is minus b by a, which is matching with what we have calculated right away. Now if you take S2, which is summation alpha beta, this will be term alpha beta, alpha gamma, beta gamma. So minus 1 raised to the power 2, coefficient of x raised to the power 3 minus 2 upon coefficient of x cube. So this will become coefficient of x raised to the power 1, which is c only. So this will become c by a. And say if I'll write s cube, this will be summation of alpha beta gamma, and it will be alpha beta gamma minus 1 raised to the power 3, coefficient of x raised to the power 3 minus 3 upon coefficient of x3, which will be d by a, or say minus d by a, because minus 1 raised to the power 3 is present. So I hope it is getting clear. You can directly, like for cubic degree 4 equation, you can easily remember it as the sum of roots taken 1 at a time is minus b by a. Okay, then plus c by a, sum of root taken 2 at a time is plus c by a, and sum of roots taken 3 at a time is minus d by a. Similarly, if I'll write, say I have a degree 4 equation, ax4 plus bx cube plus cx square plus dx plus e. The shortcut is that alternate alternate coefficients will come with the positive as well as negative sign. If I write S1, which is summation alpha, let's consider the roots are alpha, beta, gamma, delta. So this value will be alpha plus beta plus gamma plus delta. This will be equal to minus b by a. And if I'll write S2, which is alpha, beta, now I have used in this term. Now the next term will be plus c by a. Now S3, which is sigma alpha beta gamma, now I have used in this term. Next term will be minus d by alternate signs. S4 is sigma alpha beta gamma delta, which is this term is already used in, so e by a. But the problem arises when the degree is quite high. For that you need to remember that formula. Okay, so this formula should be remembered, and you can use it anywhere for any polynomial equation of degree n. I hope it is clear. Now moving on to the next topic, which is a resolution of degree 2 term into linear factors. So we have a general equation of conic, which is a degree 2 term, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. Now we want to resolve this degree 2 term into two linear factors, which is L1x m1y plus n1 equal to 0 and L2x plus m2y plus n2 equal to 0. Okay, so this is like, this can be derived, and we will be deriving this in conic section because it is a part of a conic section. But some of the questions related to this have been asked in quadratic equation, because the result is dependent on quadratic. So right now I'm just telling you the result, and for derivation you can look up at pair of straight line chapter in the conic section. So we'll just write the result. The result for this is that if you want to express this equation into two linear factors, it means you want to convert the general equation into pair of two lines. So these are two lines only. The condition is that there is a determinant AHG, HBF, GFC. This should be equal to 0. So we call it as delta. From where you can calculate AHG, the equation will be given, and you have to compare this equation with this equation, the general equation of conic, and get the coefficients out, which is A, H, G, HBF, GFC. This determinant is a symmetric one. How to solve this one, I will also tell you that. This determinant is easy to remember also. Like if you see the first row and the first column, both are same. The first row for this determinant is AHG, and the first column is also AHG. The second row is HBF, and the second column is also HBF. The third row is GFC and the third column is also GFC. Okay. Now how to open this determinant is that we open the determinant with the help of first row here. You can open it with any row or any column which you will be studying in the chapter determinant. So we'll just try to open using first row. How to do that? You have to take A, then remove all the elements of the rows and the column, and the rest, the balance elements can be cross multiplied like we were doing in the Cramer's rule, BAC minus F square. Okay. Now the next is minus H. Remove all the elements of the row containing H and the column containing H. So you will be left with HGFC and cross multiply. So you will get HC minus GF plus G into, you remove the row and the column elements, you will get HF minus BG. Okay. I hope it is clear. Look at it again. A times remove the rows and the columns, BC minus F square minus H times HC minus GF plus G times HF minus BG. So this term will be equivalent to ABC plus 2HGF minus AF square minus H square C minus BG square. If you write it in a pattern, you will get ABC plus 2FGH minus AF square minus BG square minus CH square. So this is the value of delta. So once the delta term is equal to 0, so once delta is equal to 0, which is either the determinant or this value, the GEC can be resolved into two linear factors. Okay, there was one more condition. If you, in the question it is asked that the linear factors required are real, then the condition should be delta should be equal to 0 and H square should be greater than or equal to AB. If the linear factors which are required are real, then the condition will be delta 0 and H square greater than or equal to AB. If they are not in the problem, it is not stating that the linear factors required are real, then only delta equal to 0 can be used. If it is stating that the linear factor should be real, then H square should be greater than or equal to AB must be used. Okay, this will be discussed in detail in conic section. So if you face any problem related to resolution of degree 2 term into linear factors, directly use these results.